Hello guys, welcome back to Rose Labs YouTube channel. In today's episode, we dive into like generic types and traits. And as always, if this is your first time joining us, I'll advise you go back to check out the previous episodes so you'll be able to follow effectively with this particular one. And yeah, if you've enjoyed our content thus far, I'm pleading please to subscribe, like, and share with anybody who's like interested in learning the Cairo programming language. And of course, without further ado, let's get started. So, generally in programming, there's the very popular principle, which we usually, we acronymize into like dry write, do not repeat yourself. And essentially, most times when you're writing like programs, you're building applications, you would have like certain logic which like repeats over time, right? You have this logic which repeats over and over and over again. And it's always proper practice, right? And when you have things like this, right, you abstract them into like some sort of helper function that you can just easily call. And the reason why this is important, right, is because if you maybe, let's say, like keep repeating that same logic over time, right, it's very easy to like run into bugs. Because for example, let's say you want to change something in the logic, then you'd have to like make sure you track and change every single place he appeared, right? So it doesn't really make sense. And that's the reason why things like abstracting things into like helper functions, or better still, why generics exist. So let's dive into like our code editor and probably like just get started with something. All right, so back in our code editor, and as we've always done, right, I'm going to come here and I'm going to call this BAC10, and BAC10, I'm just going to call these generic types and traits. All right, so as always, I'll just come here and I'll do scap, create a new scap folder, scap, new scap project area, and I'm just going to call, let me just call this generic. Yeah, so let's go for Cairo test. All right, so yeah, I'm just going to, our normal tradition, I will just come here and rename this, and name this to BAC thin. All right, and BAC thin, yeah, so I think that's as much as we need to do. So I'm just going to move into BAC thin. And right, so I'm just going to clear my terminal. All right, so back in BAC 10, and now just like to show an example of what I mean, right? So let's say we have this we have the simple main function, right? And you have like I don't know, okay, let's just use the logic that's very simple, something like the addition of two numbers, right? And you say, maybe you had something like let x equals to, I don't know, 30, and let y equal to like 20, and you probably had to do x plus y. Now this is the same very simple like a very simple example, right? And maybe you had to do something like that again, add another like what's it called, two different integers, right? And maybe I want to call this, let u equal to 40, and let v equal to, I don't know, 50, right? And I come here and I do u plus v, right? So you notice essentially something I've been doing repeatedly, right, is probably like adding like two integers together. So how about we kind of like abstract that into a helper function? So we could do something like, let's have a helper function. We could call that like a function add numbers. We could call that function add numbers, and that's going to maybe take like an x, let's say unit 8, and can take also a y, let's say unit 8, right? And just going to return like a unit 8, which is like the addition of the both numbers. And we can just simply come here and do like x plus y, so he adds it and returns it. So essentially, instead of doing this, right, repeating ourselves like the way we've done, we could just simply do let's z be equal to add numbers, and we're going to pass in our two numbers, in this case x and y, right? And we could also do this for u plus v, and just say let I don't know, so let's say let e be equal to add numbers, and we can just do like u and v. So essentially what we've done is, instead of repeating our logic, like we just created a helper function. It takes it like there's two arguments, it adds it and returns it. So if your goal is to do what we just did, right, and avoid repeating your codes, right? This is where generics shine. You love generics because essentially generics allow us like to write reusable codes, and the beauty of it is it works or is compatible with most data types in Cairo, right? And thus you can actually write like better codes, cleaner codes that are actually perfect and better, like easier to actually maintain. So yeah, so we're just going to hop into our code editor and basically like look at how or to get our hands dirty with like using generics. All right. So now back in our code editor, the first thing I'm going to do is I'm going to clear like the previous example we wrote, right? So I'm just going to clear this and I'm going to clear this. So what we want to do now is we're going to write a function, a helper function essentially that takes in two different arrays, kind of like compares them and returns the one which is actually like bigger. That's in this case like the bigger array, right? So the first thing we want to exactly do is we're going to create the function. Let's call this let's call this larger array, and it's like I said, it's going to take two arrays. So array one, which is going to be of type array, let's just say field 252 for now, and let's see array, let's just call this array 2, which is also going to be of array field 252. All right, and like I said, it's going to compare the both and return to us like the array which is bigger, which is also going to be a like array type of field 252, right? So now what do we want to do? So we know like if you watched like the chapter we did on the array, right? You know that if you want to get like the length, like you want to check the length of an array, you have like a method available to you, like called len. You can actually use that. So we're just going to do that. So we're going to say if array1.len, right, is greater than array2.len, then we can actually confirm that array1 is bigger. So we just want to return array1. Else, so we're going to do else. We know that array2 is bigger, and so we're just going to return array2. Now, this is like a very, very simple example of how you can actually like basically like what we're looking at how we can apply generics. But before then, I want to show you why you would want to use generics. All right, so now we're going to create two arrays. So I'm going to create array1, and array1 is going to be, let's just say, of type field 252. All right, and we're just going to create a random array. I'm just going to clear this. All right, and I'm going to just prefill it with random elements. All right, now I'm going to create another array. I'm going to say let this be array 2, right? And it's also going to be of type field 252. Right, then it's going to prefill that with random elements too. Okay. All right. Now want to check boot array and return to rows like the bigger array. Let's call that bigger array, right? And that's going to be, we're going to use the larger array function, which we just did right now. And the larger array function is going to take in the both arrays, array1 and array2, and is going to return to rows like the bigger array. And we can just print the first element of like the array we get just to confirm what's actually got returned, right? So I'm just going to say, okay, let's print bigger array at position 0. All right, so now our code is ready to go. So let's try that. And we're going to run Cairo run. And running Cairo run should print out, we should expect to get 10. So 10 is the longer array. So obviously we got like the first element of this longer array, which is 10. So it means our code logic does like what we expect it to do. But now what if we want this code to be reusable, right, for any data type at all? Now, if I try to pass in, let's say, okay, uint 8 here, and I try to pass in uint 8 here, you can see the compiler begins to shout at us, hey man, this accepts like field 252, right? So you're trying to pass in like a uint 8, so it doesn't really make sense. So in those cases are where generics right? So with generics, you're trying to like, instead of passing the particular data type, you can actually tell the compiler, okay, this is a generic data type, meaning you can actually accept any type of data type. Now, to go about this, how you want to do it is, first of all, you need to specify that you're going to be using like a generic data type, and you do that using like this sort of angular brackets. So you put this angular brackets just before like the parentheses that accepts the parameters, and you pass in like a generic value in this case, which is t. So t is like the alphabet we usually use, right, when representing generics, but it's just like some sort of convention. You can actually use any sort of data type you want to. So it can be t, it can be u, it can be v, whatever you want to write, but I would always like advise you use t. All right, so now we've done that, we can now come here and say, okay, we want this to be rather a generic data type of t, and we want this to be a generic data type of t, and we want this to be a generic data type of t. But now you can still see we still get an error. So the error says variable is not dropped. Now with generics, there are certain constraints that the compiler puts on certain data types that you need to like conform to, or you need to obey. So in this case, working with arrays, one of the things that's going to happen, right? So we're taking return one array, but we need to tell the compiler, okay, this is how I want it to drop the second array. Now, in order to do that, most times when, for example, in previous example or previous like episodes, right, when we had to do that with structs, we had to like derive the drop traits on like the struct. Now, we can also do that using generics. Now, to do that, within this angular bracket we already have, right? So we can do something like we're going to specify t drop, and we're going to say we want you, so it's going to be like an implementation, sorry. So the name of this implementation is going to be t drop, and what we want to like the generics, or what we want to implement for this like this whole particular function, right, is the drop trait. So we can just simply say I want you to implement the drop trait over the t generic type. So that's essentially what we're doing, and as you can see, once we do that, we no longer run into errors. And if we have the t type, like if we do this right, passing the t generic type, it means we should be able to like use any sort of like, so this number is too big, so I'm just going to cut it to 6. So we would now be able to use like any sort of data type we want to use. For example, it can be unit 8. We can decide, oh, okay, we want to use unit 16 to compare to unit 16. So we can just do that. Compared to unit 16, we can do that for unit 32s, unit 64s, and so on and so forth. So that's where generic shines. So like I just mentioned earlier, right, most times when you're using generics of our certain data types in Cairo, there are some like constraints that the compiler implements, which you need to like should I say conform to or something, right? For example, as you can see for the drop traits, we had to implement like we had to implement the drop traits right over like the t data type. Now let's write, or let's probably play around to write a little another helper function to basically demonstrate this. Now we're going to write, for this next case, we're going to write a function that runs through an array, right, and basically gives us the smallest element within an array, and within that we're going to basically use like some sort of like comparison. So let's just write our function to and basically explain as we write down. So we're going to write a new function. This function is going to be called, let's call it smallest element. And now this function, like I said, is going to be generic over the t type, just as we just did, right? And it's going to it's going to take in an array. It's going to take in an array, right? This array is going to be of like a generic type t. And it's going to return the t data type, right? So essentially, time around, we're not returning the whole array, right? But we're just returning like a particular element in the array, which is of course like of the t data type. Now what we're going to do is we're going to store the first element in this. We're going to create a smallest variable and store the first element in it, right? So that's the first element in the array. Remember I said we're going to like iterate, like run through the whole array, right? And we're going to like return the smallest element. Now the first element is what we want to get first, and we're going to keep comparing against that element to see if like there's any other smaller element. If there is, then we want to drop that element and pick that, like drop the first element, or like update the smallest variable, right, to hold that element. So what we're going to do is we want to use like some sort of while loop to like iterate or move through the array and get each element and compare it against the smallest. But to do that, we need like some sort of index to track what index we are on, right? So I'm going to create an index variable, and we're just going to initiate that to 1. So we already have the position 0 held at smallest. Now the next thing we want to compare against, right, is like the index 1. All right, and now I'm going to now use the while loop, and we're going to see while the index, right, is less than the length of the array. Remember, array starts from the index starts from 0. So we want to ensure we're comparing like that against like the array dot length, that it's always less than the array dot length. So now what we're checking, the index should be less than the length of the array. And in as much as that is true, right? In as much as that, the expression evaluates to true, our while loop will continue to run. All right. So what we want to do is we're going to compare like at that particular index. Going to compare at that particular index, right? We're going to check. Okay. Are you, what we're doing basically is we're saying, okay, if the element at this particular index within the array is less than the smallest, then what we want to simply do is we want to update that smallest value, right? And we're going to we're going to give it like that element at that particular index in the array. So essentially saying if this element at this particular index is less than smallest, then maybe it might be the smallest element. So let's replace the element within the smallest variable with this particular element. So that's what we're essentially doing. Now remember that we're checking the indexes less than the array length or length. So we want to ensure when we get to the last element in the array, we want to stop iterating to it. So it means every single time we go, we want to increase like our index, right? So we want to say index plus should be equal to 1, right? We want to increase the index. So every single time we go, increase the index and stuff. So by the time we get to the end of the array, we should have gotten like the smallest element. So once we're done with that, we're just going to simply return like that smallest element we got, and that should fix it for us. Now you can see we still have an array, and what's it got the problem though? Now if you come here to hover over the problem, you'll see that it says this trait has no implementation in context, core traits partial or t. Now these are the constraints I was talking about, right? So essentially for you to do this comparison, it means the t type which we are iterating over, right? The t type has to implement this partial or trait. So we're going to use generics once again to do that. What we're going to do, like we just did, right, is we're going to implement let's call this t partial odd, and that is just going to simply be the implementation. We're going to say, okay, we want you to use the partial or trait over t. But now you can see we now have a lot of issues. First of all, we need to also drop the array traits, just like as we did the first time. So this will say variable not dropped. That's one. Secondly, we are snapping this and trying to copy it into here. So it means we have to implement like the copy trait on the t type. So we have to, it means, like I said, first of all, we want to implement the drop trait. That's another constraint that we need to like conform to, right? And we need the copy traits too. So I'm just going to call this t copy, and t copy is going to be copy t. Now, after we've done all those, you can see we no longer have errors. So we're going to try our function and see if it works essentially. So I'm going to go back into our main function. And what I'm going to do is I'm going to create another array. So we're going to call this, let's call this array 3. And it can be of any type, or I'll probably just, let me start with the fields 252. Okay. Now the field 252 also does not really implement, like, supports the comparison or comparison operators. That's the greater than, less than. So we have to use like an integer. All right. So I'm going to use int 16 in this case, and right, I'm going to just pass in a random array. All right. So now, if you look at this, right, we already can see that our smallest element is 1. So let's see what gets returned 0. So I'm going to just simply say let smallest value be equal to, we're going to call the smallest element function, and we're going to pass in our array 3. All right. Now we want to print out that smallest value. So I'm going to just print out that smallest value here. Now let's see what we get. I'm going to clear this, and I'm going to run scarp Cairo run again. And you can see we get our smallest element, which is in this case 1. All right, so now being able to like implement like generics, right, for our smallest element function, we can even make this a lot cleaner because as you can see, the code is unnecessarily long and a bit complicated. Now, something you can take note of, right, is this implementation we create, we actually don't use it anywhere in our function logic. So all we're just trying to do, right, is like to specify the use of like tell the compiler to like use or derive this particular traits, right, this partial or drop traits, copy trait, and so on and so forth. We can actually do it in a more cleaner manner, right? So we could just remove this and just add the plus operator. So I'm just going to clear this and I'm going to use like the plus operator. Now this plus operator does similar thing, right? It just tells the compiler, okay, we want to use like the partial or traits within like for the, over this generic type. We can do the same for drop traits. So I'm just going to clear this and I'm going to just add the plus sign, and we can do this for like the copy trait too. So I'm just going to clear this and I'm going to just add the plus sign. So as you can see, this is now a lot more simpler, easier to read, and a lot more cleaner. So that's something else you need to keep in mind, the use of like this partial or the use of like this operator here. All right, so now we've looked at how you can basically like use generic within functions, but that's not just where what it's restricted to. You can actually use them with specify generic types of custom data types like structs and enums. Now let's look at how you're going to do that. All right, so we just did all this, so I'm just going to go up and I'm going to create like a struct. So we're going to create a struct and I'm going to call the struct like wallet, right? And I want normally always well we always create a struct and I'll probably specify let's say for example that maybe we want the balance to let's say be in 256 and we want the address to be let's say maybe a contract. Okay, we can use that here. So maybe use like I don't know, unit 8 or whatever it is, right? So we'll usually specify the struct item and the data type, but you can actually like do this using generics. If you want your struct to be usable like by a lot of data types, right? You can actually specify or tell like the compiler to do that. So to do that, we're going to come in here and we're going to say, okay, we want the struct wallet to be generic over the type T. So when we do something like this, right, we can now come in here and I'm going to say, okay, maybe I want the balance to use like I want the balance to use like that generic data type. So the balance is going to be generic over that. And you can actually even use like multiple generics. So I don't think we've tried that out, but you can actually do something like, okay, I want you to use like I want you to use like V, different generic data types. Like I said, it doesn't have to be T. You can use like different other alphabets. And I can come here and I said, I want address to be like of the generic type U. And I want like, what's it called? Maybe any other thing, right? Person, I don't know, whatever, to be of like type V. So you can do all this. You can actually like do all this. You can actually even do what's it called? I think when we looked at structs, that was like maybe episode 3 episodes back, right? We talked about how you could actually like write custom traits and implementations for your structs, right? And you could actually even do that over generic types. So let's say I want to write the traits, right, for this particular struct. I could do something like, okay, I want this trait called wallet trait. So and I want this trait wallet trait to be generic over like the type T. And essentially what I'm just going to do is I want to specify like the interface or like the functions that should be contained in this trait. And one of them should be like the balance function, and this function is going to take itself like to a reference to that struct, right, which is the wallet T. And I want you to just return like the balance, which is of type T, something like this, right? And that way we've just specified like a trait or like basically a trait, right, that's generic over the type T. Something I forgot to mention, right, is like when we talked about structure, we talked about how they had to implement the drop trait because you have to like tell the compiler how like to drop a particular struct after it goes out of use, right? So now we're not really going to do some of all the theatrics we did here, right? Now all the things what we've probably done before still like it still counts, is valid. So we could just simply use that, add that using like the derive macro. So I'm just going to say, okay, I want you to like derive drop, and that should like work perfectly for us. All right, so now the way have written traits too, we can actually even write implement an implementation for this trait. So I'm just simply going to come here and I'm going to say I want to write an implementation. I'm going to call this wallet implementation. And wallet implementation, I want it, of course, to be generic over the type T, and it's going to implement like the wallet trait, and the wallet trait in itself is generic over the type T. And now I'm going to write all the functions within like my implementation. Now the function I have is like the balance function, and this balance function, it takes in like the self, and which is of course wallet t. So if you're wondering why we're passing in self, now self in itself is like we explained like when we looked at the chapter or the episode on structs, right? We explained that when you pass in self as the first argument to methods, right? Methods are like basically like functions essentially you could call using like the dot notation. I'm going to show you how you can call methods, right? So now we have the balance function, and this is supposed to return like data type T, and we can just simply just call self not balance. So balance, remember balance is like the element within the wallet T, so we're just referring to that, right? So now let's say I want to create a new instantiate a new wallet and get the balance. I could just simply come into my main function, and I'm going to do something like I'm going to say I want the wallet, and this wallet is going to be, let's say, wallet, and maybe it's going to be of type let's say you're into 6 this time around, and this is going to just be wallet, and I'm going to pass in a balance, and the balance is going to be, let's say, 50, right? And I'm going to just simply to get my balance right, so I could just print out that. So I'm going to print out my balance, and if we do this right and print out wallet dot balance, now you can see where methods comes in, right? So we're referring to this balance function, and we can just call it using like the dot sign, so doing like something like this. So we can just, because it's a method, we can call it using this. All right, so now let's try to print out that. So I'm just going to come. All right, so let's just try to print out that, right? So I'm going to clear this the scarp Cairo run, and we should be able to like we should get the balance, which is 50. So just like that, we'll like implemented traits and implementation. We've written traits and written implementations, right, for the struct, which is implements like a generic item. And it simply means we can also do this like, right, with different data types, a UN16, a UN32, and so on and so forth. All right. So the same way we've done it over structs, right, we could also even do that over enums. Like a very popular type, right, is the option enums we looked at, like I think in the last episode, and we've talked about from time to time, right? So the option enum is something in the core library, and the option enum essentially takes in like a generic type T, and what it does essentially is it has this the sum element, some variant, which returns T if there's like a variant at the none, which does not really return anything. So this is what like the option enum looks like. So that's why you can use it with like any data type at all. We also have like another popular enum in the core library, which is the result enum. And what the result enum does, basically it's generic over 2 items in this case, which is like T and E, right? And what it essentially does is it checks, okay, if this is okay, that's if like a particular operation you're carrying out, if it succeeds, returns okay with like a T, right? And if it fails, it returns an error with type E. So that's another enum, right? That's essentially how you can use like a generics with enum. You pass data type as our associate data type with like the corresponding variants. All right, so let's go back into our Cairo book and see if we're missing anything else before like we move into our next sub chapter. All right, so back in our Cairo book, we've looked at generic data types, we've looked at functions, we've looked at constraints. We talked about constraints. We've also looked at like the anonymous operator. We've looked at structs. We looked at enums. So there's other stuff you can actually like try out on your own. And so we're going to move into like our next sub chapter. So the last thing we're going to be taking a look at in this particular episode is traits. So traits is something we've mentioned and we've probably used like probably multiple times within this particular series, and you've probably not been able to like get a full grasp of it. So that's what we're going to try to do in like this sub chapter. All right. So think of traits as behaviors, like you're specifying, okay, this is how I want like a particular object to behave, right? So essentially they are like a set of methods that can be implemented by a particular type. Now traits work perfectly well with generics, because most times when you use like a generic on like a trait and its implementation, you're essentially saying that this is a particular behavior, this is a particular implementation, these are methods, right, that different let's say different stocks or different items, right, they share this behavior. For example, I could decide, okay, I want to implement like a generic trait called animal that is generic over type T, and maybe I have like different struct items such as let's say bird, or goat, cow, and whatever it is, right, and they would be able to implement, or they share the behaviors which you find within that particular like a trait and its implementation. So let's jump into like our code editor and basically like play around with traits to understand it better. All right, now back in our code editor, and the first thing we're probably going to do is just to make sure this is easier for you when you try to check it out. I'm going to create a new file in here. I'm going to call this, let's call this generics. Let's call this generics. That's Cairo. I'm going to create another one. I'm going to call this Cairo, and I'm going to just move for like our contents of lib.cairo. I'm going to cut it and I'm going to paste it in generics, and we can just make reference to it here saying mode generics, right? But I'm just going to comment that out so it doesn't interfere with like maybe whatever we're going to print out when we begin to look at traits. All right, so I'm just going to say mod traits instead. All right, now we want to look at traits, and essentially I already explained like traits are basically like behaviors, methods. You go basically specifying, okay, these are the methods that this particular object implements. Now we started with like our examples of like using animals, right? So we're going to just start with that. All right, so as always, when you're specifying structure, right, we're going to first derive like the drop. We're going to derive the drop trait. We're going to define a single struct. Let's call this I'm going to call it let's call it a cat, right? And this cat, we're going to like maybe like just specify the noise it makes, right? And I'm just going to make it a field 252. So when we call the cat, we want to like specify the particular noise it makes. All right, now we can write a trait for this cat. So I'm just going to call this cat trait, right? And what the cat trait does basically is it has like let's say just call let's call this noise, right? This takes like self cat, which is like a reference to like the cat. And yeah, so it's going to just return a field 252, which is essentially the noise like that this particular cat makes, right? So there's a function, so let's not forget that. All right, now we're going to write an implementation for this. So I'm going to come here and I'm going to say cat implementation, right? And it's going to be implementation, like the cat implementation, we want it to use like the cat trait, right? So it's going to be of the cat trait. And essentially what this is just going to do is essentially is going to implement the noise, and it takes in the self, which is cat, and returns like a field 252. All right. And what exactly is the noise a cat makes, right? It's just a meow. So we're just going to return that, a meow. All right. Now, if we try to use that within a main function, so we create a main function and we want to use that, right? So we're just going to instantiate the cat objects, right? And all right, so essentially we just okay, so something I'm going to do, right, is let's remove this. So maybe I don't know, let's say sorry, nothing comes to mind, right? So I'll just say properties, and or let's just call them features instead. So I'm just going to say features and specify like the features it has, maybe like with the filter so I'm just going to just do that features, and the features I want to specify maybe whiskers, right? All right, so just ignore that terrible example, I know. All right, now I want to call to make the cat meow or like see something, right? So I could just simply do like cat.noise. Remember, that's now a method which is like implemented on it, right? So I could just simply do like cat.noise and it's going to like meow. So let's try to print that and see what that shows us. So I'm just going to print that, and Yeah. All right. So I'm going to try to print that. And let's just clear out terminal landscape Cairo run. All right, so you can see this field 252 is printed, which is basically like the representation of meow in field 252, right? So that's essentially like the simplest definition of what a treat is. So we specify an object called cat, right? And we specify like a behavior it has, which is like it can make a noise. And what does the noise sound like? A meow. Now, I mentioned something about how you can actually like use generic traits, but before then, maybe let's try another example to where we also like make use of like traits, or very right traits and implementation, right? So I could actually like okay, before we go into that, let's just look into like, so we don't stray very far from the animal example, right? So what if we want to actually what if we had multiple struct objects? So just the way we have cards, we have maybe a dog, and we have maybe a cow. So I'm just going to call this a dog, and I'm going to call this a cow. Now, these are all different animals, right? And we want to say, okay, these animals, they have like some certain features that they share, and we want to like specify that. So now these are all animals, right? So I want to say, okay, this traits, I want to call this trait animal, right? And animal traits rather, animal traits, right? And there are different features that these animals they share. But one thing we need to take note of, right, is the fact that we want this trait to be generic. We want to be able to use it on cows, on dogs, and even cats too. So I'm going to come here, and like we did in our previous example, sorry, like when we looked at generics, right? We're going to specify, okay, this animal trait should be generic over type T, so we should be able to pass in any animal object in there. All right. So now I want to specify, okay, or any of these animals, right? Something they can do is they can walk. So when we do this, we want to just simply return, what will I return? Okay, let's do something fun. All right. So I wanted to, okay, no, we'll just complicate things. All right. So what we're just going to do, right, is just do the same thing. Just make it simple. Felt 252, right? And remember, this is like the same traits. They can walk. So something else we can also do, right, is we can also specify all of them can make noise, can't they? So we can also do that, right? So they can all make noise, and we want to like return like a felt 252 for like the different noise they make. So now something I can rather do here now is just similar to what we did for the features, right? I'm going to add each of the noise they all make. So I know we also, okay, well, let's not call this noise. So I'm just going to call this sound. Let's call this sound. That'll be better. And it's going to be a felt 252. Right. I know, like I said, they're not the best examples, so I hope they kind of like communicate what I'm trying to communicate. So we have sound, which is going to be felt 252, sound for dogs, and we have sound, which is also going to be like a felt 252 once again, right? And now what do we want to do? We want to take in these animal traits essentially and return like the how they work and the noise that they make, right? So I'm going to write implementation for this, right? So I'm going to come here and I'm going to write implementation. Let's call this animal implementation, and it's going to be all like the animal traits. All right. And the first thing I want to do, remember, one thing you need to take note of, right, is, what is it called? The animal implementation is going to be generic over type T. The animal trait is also was generic over type T. So we have to add that here. So animal implementation and, these two over type T, right? So now once we have that, we need to implement these two functions within here. So the first function is walk, and it takes in self T and returns like a felt 252. All right, so what do we want to do? Well, I'm just going to say walk. Variable example I know, but we're just going to do that. Okay, so variable not dropped. All right, so we want to we're just going to do what we did earlier. So wants to do this, right? Say, okay, I want you to implement like the drop generic trait, and should fix our error. All right, now we want to also implement for like is this sound, what was it called, noise? So I'm going to write for the noise, and it takes in self t once again and returns again a failed to 52. And this time around, I just want to make a reference to self.sound. So this should be here. Um, let's see. Type T has no members. Okay. I see. Okay. I think I know what's wrong. So we're not exactly passing in, we're not implementing it over these types. If we want to do something like this, then we have to like, distinctly specify that, okay, we want this to be over this type or over this type or over this type. For example, if I came here and I said, okay, this implementation should be over cows, right? And let's say, um, we're just going to clear all this. Right. So if we do this, then we want to pass in self as cow, right? And we're going to pass this in as cow too. And when we do that, we can now have access to like self.cow, self.sound, which is basically like the what's it called? The sound that cows make. So we can't just write a generic implementation instead. So we just have to do this rather. So we're essentially going to, so in this case, I'm going to have to unfortunately call this like cow implementation, and it's going to implement the animal traits regardless, but over like the cow type. So I can do that too. I'm just going to copy and paste that because of time, and we can do that for, let's say, over the dog implementation. So I'm just going to call that dog implementation, and the type T we want to pass in, right, is going to be like the dog type, and we're just going to pass in the dog and the dog. All right. So now when we've done all this, if we want to like how do I put it, right? So if we want to use this, right, within our main functions, oh, this is now shouting, right? Because we added a new menu struct item, so we have to represent that. So I'm just going to say sound, and the sound is going to be meow. So now we've done all these things, we could basically just specify like come here and maybe say create a new item called this dog, and for features I'm just going to pass in claw, and for sound I'm going to, let's say, pass in back, and yeah, so I can now come here and once again maybe try to print out in this case, let's see, we can see dog dot sound, which is like sorry, dog.noise, right, which is like a general trait, animal traits, right? And we wrote an implementation for dog. So for dog, basically we wrote it's going to throw back the sound in this case, which is back. And we could also do something similar for walk, right? Maybe print out in this case dog.walk, and that's just going to basically, okay, this is going to tell us the traits was previously moved. So then, but then you kind of like get the gist. So we're just going to skip that for now. And you can also do that for cows, so which also has the we can say, okay, features. What else come? Let's say cows they do have like breast from which milk comes out, so I'm just going to pass that in. Then for sound I'm just going to what sounds do they make again? I think cows probably moot or something, I don't know what's called, but let's assume that's what's called, right? And so we can just print that out too, right? So print that out, and next time around we could maybe do like cow dot walk, right? Until that's just it essentially. So if we compile this and maybe run this, we're going to get all those values, right? But probably like they are failed to representation. Something that probably done is just used like byte arrays to get them in like their normal format. But anyways, I think like this kinds of like gives you like an idea of like how traits are. So essentially, like we said, traits are how you specify the behaviors that should like a particular struct item, a particular type should implement, right? So in this case, for example, for cats, we said, okay, the behavior of cats, right, is that they make some certain noise. When you write traits, of course, you have to write the implementation. So the implementation is kind of like how you specify the logic or the things that are supposed to happen when that particular function, trait, or whatever is called, right? So think of traits as interface that defines like the behavior of that type, and the implementation basically contains the implementation of the logic that is performed when that particular method or function is called. And like I said, even method is specified using traits, right? You can always call it using like the dot notation. Another thing you can also note of, right, is you can create generic traits using like the T type and non-specified custom implementation. For example, dogs and cows and animals, and we see they can both walk and make noise, and those you can just pass that in as a generic like trait T, and then pass it like the different types and write implementations for them. All right, so because of time, we're going to like be stopping here for this particular episode. I'm going to continue in the next. So if you did enjoy this particular episode, please, as always, do like, subscribe, and hit the notification bell so you are informed every time we drop a new video. And with that, I will see you in the next one.